Bill Shuster is the professor of civil engineering, civil and environmental engineering at Wayne State University in Detroit, Michigan. His research focuses on urban hydrology and rendering of ecosystem services from urbanized landscapes. Bill, thank you so much for taking the time today.
I appreciate you inviting me. Thank you.
I'd love to start just by asking, what is urban hydrology and why is it important?
So, urban hydrology, when we talk about hydrology in general, it's how water cycles through our world, our environment. And so whenever it rains or snows or we irrigate, um, that is what we call an input to our hydrologic cycle. Because of course we have to feed, our lakes, our rivers, and and so when that rainfall soaks into the landscape, it's called infiltration. And and so when the water doesn't infiltrate or move into the soil, or it hits a hard surface like a road, then it runs off. And so, and we'll get to the importance of that uh, during the course of our conversation. Um, the of course we have to grow plants and sustain, you know, vegetation or flora in all its different forms because it sustains us. And so we have to get water into the soil, into the root zones of flora. Um, and so as a physiological imperative, our plants actually take up that water uh, to, so that they can engage in what we call primary production and actually grow and flourish. Um, and so we get also our flora actually blows off water. It's brought up from the soil through the root zone and then moves as transpiration is what we call it. So that's actually a loss in, but we're cycling water through our environment. We also have groundwater. Uh, and so many of our cities and states around the world depend on groundwater to pull it out of the ground and do irrigation or uh, process that water for drinking water. If you're not close to a lake or an ocean, and that would be your water source. And so we, I think we've all heard about how groundwater is a precious resource as well. Um, it's a limited source of fresh water. So the the really important point I want to make here is that when we come in and create our human centered development, our cities and other conurbations, um, we we create we change the hydrologic cycle. There's no doubt about it. We lay down hard surfaces, we build houses with roofs, and as I pointed out earlier, as the rain or hits or the snow melts or we over irrigate a lawn, for example, we get runoff, and so we move from um, what was previously a landscape that pretty much took in all the water we could throw at it, but now it's a runoff dominated system, and we have to do something with that runoff in our cities. And so we have extensive and very elaborate sewer systems to uh, to take in that water, that runoff, and move it around, process it, and generally uh, sustain our ability to get around our cities, that we can travel unfettered, that we don't have um, water, getting into our houses or sewer systems function on like a suitable level to provide these 365, 24/7 services that we've all come to expect. That we get drinking water when we turn on, it's reasonably safe. And but what's happened is that as our systems have aged to manage this runoff dominated system, um, we encounter different types of flooding, and with we often look at this as we're getting sandwiched between changes in our climate and changes in the frequency and depth of precipitation, changes in the patterns of rainfall and snowfall. and um, and then the other part of the vase or the sandwich would be their infrastructure is old. And as we move through time, um, the extent that we've operated and maintained that infrastructure, there's been quite a gap forming. So you not only have more water or less water, you know the important concept here is we have change, and it's moving in uncertain directions, and we don't, how do we manage these changes in our hydrologic cycle to maintain the services that we depend on. So um, one of the career spanning aspects of urban hydrology that I look at is well, how well do our landscapes take in water? Can we leverage these landscapes to help us manage the uh, flows, like the inputs of, again, rainfall, snow melt, irrigation, and that help us understand, okay, I can put this much into the sewer system, but if I put any more, we're going to start getting sewer backups, like the system is going to flood streets. Um, and, maybe we have a river nearby that the stage or the level of the river goes up and down. And, what can we do to manage risks from that? What can we take data on groundwater level? Is that groundwater level at the same level as your basement, or in a slab structure? Is it starting to put pressure on the slab? And so this is all very important because our soils are the mediators of that. If we haven't paved over or made it, covered it in a hard surface, our soils can really help, soak up that, that excess stormwater runoff. Um, However, in our ultra urban areas, where there's much more impervious area, those hard surfaces, that's the term that we use to refer to the hard surfaces, roads, roofs, sidewalks, anything that won't allow water to infiltrate or move into the soil. But the more we know about the ability of those soils that are available, um, in vegetated landscapes, and it turns out that in some cities we have a lot of vacant lots and vacant spaces, and over the course of my career with the federal U.S. Environmental Protection Agency, where I served as a research hydrologist, and presently in my work as a professor here at Wayne State University in Detroit, um, we're starting to, I've coined this term data equity. We don't know a lot about our post-urban spaces, our vacant lots, and it's so important again to take the data and use that data to understand, well, hey, we've got options here. Perhaps in these almost rural areas in our course, the core areas of our cities, like New Orleans, Camden, New Jersey, Cleveland, Ohio, Detroit, um, to a lesser extent, um, Omaha, that, but wherever we have areas where there was, where, blight was controlled through basically blight policy was demolition. And so we took a lot of data across the United States and started to integrate and understand, well, what is an urbanized soil and how does that change the ability of water, like the momentum and, the mass of water, the study of hydraulics into soils, and can we start to leverage these forgotten areas of our cities toward providing what are known as ecosystem services. Now, ecosystem services are defined as services of value to humans that come from a functional ecosystem. And so what is an ecosystem? Well, we have living and non-living parts of everywhere. We happen, us human critters happen to be the, a living part. We have carbon and, we move around, we're functional. But we have non-living parts like sand, silt, and clay in our soils, concrete. But how in an ecosystem, these living, biotic, and non-living, abiotic parts interact to create, good things or benefits to humans. We rely a lot on ecosystem services like agriculture, food production. But in this specific case, what we're looking at is regulation of stormwater runoff. That's a regulating ecosystem service. And so what's exciting about this work is that we can then designate on the basis of actual field data where we've gone out and consistently measured and use this data to understand and assess and characterize these landscapes. We can, what we've found through this, actually paying attention to these understudied areas in what I call data equity, passive green infrastructure. We hear a lot about rain gardens or rain barrels and different types of green infrastructure, often framed as a magic bullet to solve all of society's problems, including stormwater runoff and flooding. But this passive green infrastructure, these landscapes throughout our country, we need to account for the services that they provide in terms of stormwater runoff regulation and doing something, beneficial. These, again, largely forgotten parcels of land, which can be quite extensive. This is a good time to bring up the classical definition of green infrastructure. is extensive and contiguous vegetated land. And are we still
Yeah,
on?
yeah, we're still
Yeah,
good.
there was a freeze for a moment there, so I just wanted to make sure we're cool. And so, for example, on the coastal east side of Detroit, Michigan, we have about 30% of that landmass in extensive and contiguous vegetated land. And this is habitat. This is without any management input or spending cash for management, other than maybe the city mowing these areas once or twice per year. We're getting ecosystem services, and so how do we leverage those most effectively toward the overall societal goal of keeping water out of basements, keeping our sewer system um, at least at a level where it's not being constantly overwhelmed, by these changes in rainfall, snowfall, um, managing our irrigation properly. So this is what ecosystem services in urbanized landscapes look like. And an urbanized landscape can really be anywhere, again, us human critters have made our mark. Can be in our suburbs, our exurbs. It can be in rural areas. It can be in our farms. Um, but any part that we can manage more effectively as permeable surface rather than impermeable. And every soil, every landscape has a different capacity to take in water and move it around within the soil. But if you don't measure it, then you're depending on age-old, um, tables of very general numbers and figures, which really have no meaning in our modern world. And so getting out there and doing the field work and and touching landscape and interacting with residents and building a dialogue. It's like, well, what are you seeing in your neighborhood? In Cleveland, uh, a resident in a particularly vacant area uh, told me, it's just more and more like the farm I grew up on every day. And for others, it's different with every city. And New Orleans, it was like, well, what are you going to do here? We haven't seen anybody here since Katrina. What does this have to do with getting my neighborhood back together? Very valid question. And um, it was also a forum for being real with folks and saying, hey, we're here um, to understand the basic science of what is a urbanized soil. And we'd be taking these deep soil borings and go back tens of thousands of years in the development of that city and landscape. But in the first 2 meters of that, from the surface, down about 6 feet, 2 meters, that would be modern history. Like, hey, this is where um, there was a trash dump. This is where there was a house that once stood. Um, and so it was a vigorous, it usually turned into a vigorous discussion of, what's affecting you and your ability to live here. Um, and gave me insight as a scientist and engineer say, hey, what can I do with this data to create a better demolition approach? This is where, I coined the term demolition science. It's like, well, if we demolish a house and leave it and, just push everything into the basement, well, we're not really getting anything out of that. I mean, that's a wasted opportunity. So if we're actually putting forth the effort to remove the basement and perhaps deconstruct the house before, busting it down, um, and then making sure that what needs to go to the landfill goes to the landfill, but what can be reused is reused. Um, and then we respect the future of that landscape and the people in the neighborhood, that if they're going to have vacant land, can we at least make that vacant land uh, present with options into the future? And that includes, you know, using decent soils to backfill the area. Uh, because of course, when you remove the house and the basement, you've got an excavation. And can we be kind, to the future, or look into the future, say, hey, well, could this be a farm? Could this be a new house? Could this be a park? But it's setting the table so that we can reuse, reduce, and recycle, like any kind of expensive input. And you don't want, like there's a concept of sustainability. You don't have to go back and do things over and over again. And if I have to go back and pull everything out of the basement and, demolish the basement floor and the foundation walls, that could set back any kind of redevelopment. You know, it may never happen because we don't have a lot of resources in our urban areas for this. So doing it right the first time. And so with my EPA colleagues in EPA Region 5, this was probably 2012, we came up with a sample demolition policy on the road to reuse. And it was really inspiring to work on that, because we were incorporating the conversations and the dialogues that we had with Americans around the country to understand their way of talking, their vocabularies, their needs, and making the demolition process accountable. So under the best of conditions, when we take the idea of demolition science, we're applying, scientific method, posing a question and answering that question with measurements that are taken in a consistent manner and analyzed in a consistent manner, and then turning that into policy. This is what, basically the data suggests, and this is what the people suggest. And, we want to make sure that their landscapes, that there's some respect in there. And so this all channels from understandings of hydrology, hydraulics, soil science, and then that turns into an interdisciplinary experience of, for example, demolition science. So this is not easy. This is not ideal. This is messy, because by working in urban core areas that have been largely forgotten or written off. Um, there's the idea of data inequity. We have exclusion from, these services that most of us take for granted. Uh, Many of the cities that I've worked in over the last 25 years didn't have regular trash pickup, didn't have, much less any kind of, being able to participate in recycling programs, street lights, just basic road maintenance. Um, and so this inequity and this exclusion from, being able to fully participate in what, society, what we would, I think, customarily associate with living in an organized society. Um, why aren't we getting the same levels of services? And this is often due to racialization of infrastructure, where, you know, some infrastructure you get operation and maintenance. Um, other areas of the city, you might get operation, but you don't get maintenance. And so as go back to that vise or that sandwich where we have a changing pattern, precipitation, rainfall, snow melt, and then we have a degrading infrastructure or an infrastructure that's, basically falling apart over time. And so how do we rectify that? And that's where, again, assessment, knowing what the scope of the problem is, and using consistent methods to, again, characterize the conditions. And then, like we have a menu of different engineering technologies that we can apply to staunch, flooding in its different forms. And so that's where I'm at now in my career is communicating with residents in Detroit and understanding, how do you see this? What's the, we have different ways of communicating about what's affecting us and the extent of these. And when I ask questions, and I do more listening. I would say that 75% of my work, as a scientist or engineer is listening. About 25%, I draw on my technical. There's a time and a place for that, draw on my technical training and experience. But going back to flooding, um, my basement is flooded. Is it clear water? Does it smell? How often? And so we start to develop a shared vocabulary, and that really improves our ability to communicate very specifically about what's happening in our neighborhoods. Um, and so then there's a menu of different options that becomes available, and we can be very specific then about, well, this option might work. These other options probably won't work, and then we go to the next level. Well, our municipal service providers can do X, Y, and Z, but at the residential level, the ratepayer level, it's so important to reduce their vulnerability or risk of encountering flooding in any different form. And this is where it gets very edgy and very involved, because is there a willingness of the municipal service provider to help reduce that risk for
Yeah.
everybody.
So
Um,
I wonder if you could kind of talk about we only got a couple minutes left, but I want to uh, kind of encapsulate a lot of what you've talked about. The what advice would you give to both residents and also those municipalities that are looking at their urban hydrology, their soil, and their built environment, and thinking about what to do? What's kind of your key takeaway that you would want both residents and municipalities to think about?
we have a reckoning here. The infrastructure that was built that provides the services that we've come to depend on is in excess of 100 years old, and it's operated well under the expected service life of 50 years. Um, but we have to have an honest conversation that our infrastructure is not in good shape. And what can we do to renew that infrastructure or take the pressure off it so that people are not encountering life-changing experiences like getting, basically septic sewage back up into your house on a regular basis, of having the evolution of a structural mold population, infection in your house, which is a major public health issue. Um, and so having that conversation that this is the reality of the situation and that there's a bit of a social contract here to work on these. To the credit of Detroit Water and Sewage Department, they have instituted programs to reduce vulnerability of individual residents and homeowners. Um, and I think, this is by using appropriate technologies to come in and, okay, we have a backflow preventing check valve that we're going to put in your residential sewer lateral so that water goes one way and doesn't come back into your house. We're going to install sump pumps in the basement to reduce the groundwater pressure, that there's water getting into your basement and, supporting, uh, mold development on your walls. So that would be the biggest takeaway. When we understand and characterize and assess the system using scientific method, then we understand the scope of the issue and the menu of technologies that do or don't, won't qualify to support residents, businesses, um, and the overall health of our cities, in the face of, again, this kind of vise-like, interaction between broken infrastructure and increased pressure due to, changes in our precipitation
Yeah.
regimes.
Well, Bill, I really appreciate you taking the time to share your insights and talk to us about urban hydrology. Thank you again so much for taking the time today, and I hope we can continue the conversation down the road.
Gotcha. You're welcome.